We're discussing uh, week four classes, where few topics from the course multivariable calculus has been taught, such as Lagrange multiplier, Taylor's theorem, error approximation, polar curves, and multiple integrals. So we're gonna be solving some questions from all of this topic, and which will be helpful to solve the assignment problems in the corresponding week. So first we're gonna write the topics that has been covered in this week. So the first one is the Lagrange multipliers. Lagrange multipliers. Second one is Taylor's theorem. So this is Taylor's theorem in for multivariable function, specifically for two variable functions. Third one is the error approximation. Error approximation for Taylor's theorem. I mean, up to a certain degree. Error approximation. Fourth one was taught polar curves. So like how to trace some of the polar curves and how to change from Cartesian coordinate to polar coordinate or polar coordinate to Cartesian coordinate. So this is polar curves. And the fifth one is the multiple integrals. Okay, so these are the topics which has been covered in this week. So we're gonna be solving some questions from probably each of the topics, and we'll see how it's going. Okay, so we'll start with our first question, which is question number 1. Okay, so find the equivalent Cartesian coordinate Cartesian coordinate uh, or following the Cartesian equation, not coordinate. Of the polar equation r equals to 3 divided by sine theta minus 5 cos theta. Okay, so solution. Okay, so it can be the vice versa as well. So they may ask, they may give a Cartesian equation, and they can ask to change into a polar equation. And to do so, in this case, we have to change from polar to Cartesian equation. So to do so, we're gonna replace x with r cos theta, okay, and y to r sin theta. So in this case, x square plus y square is gonna be r square, and theta will gonna be tan inverse of y by x. So this is from polar to Cartesian. Okay. And similarly, also we can apply the same equation from going from Cartesian to polar. Okay. So now we can see that r times cos theta minus sorry, so this is going to be sin theta minus 5 cos theta, sin theta minus 5 cos theta equals to 3. So this will imply r sin theta minus 5r cos theta equals to 3. So now we already know x equals to r cos theta and y equals to r sin theta. Correct? So this will imply y minus 5x equals to 3. So this will be y equals to 5x plus 3. Okay. So this is nothing but a straight line. Okay. So I hope this is clear. So the Cartesian equation is y equals to 5x plus 3. Okay. So yeah, let us go to the next question. So there is another polar equation, and we have to change the polar equation to a Cartesian equation. And the polar equation is given by r equals to 3 sin theta divided by sine square theta minus 5 cos square of theta. Okay. So to solve this question, we're gonna be multiplying both sides. I mean, we're gonna be multiplying the fraction to the left side, so which will be r times sine square theta minus 5 of cos square theta, and then we'll be replacing x by r cos theta and y by r sin theta. That is just the Cartesian coordinate. So this will imply r times sine square theta minus 5r cos square theta equals to 3 sin theta. Okay. So now see that on the left side there is an r which is multiplied with sin theta and cos theta respectively, but on the right side there is no r. So that means to get our x equals to r cos theta and y equals to r sin theta, we need to multiply both sides by r. Okay, because r is greater than 0, we can multiply both sides. Even we can multiply by any number. So this will be r square. So let me write it by black pen. So it will be r square sine square theta minus 5r square cos square theta equals to 3r sin theta. Okay. So now since r sin theta equals to y, so this will be y square, and this will be, so since r square cos square theta is nothing but x square, so this will be x whole square, and this will be 3 times y. So this is implying that y square minus 5x square minus 3y equals to 0. Correct? And this can be also written in a compact form if you want to do so. So this is just y square minus 2 times y, so time 3 by 2 plus 9 by 4 minus 9 by 4 minus 5x square equals to 0. So this will imply y minus 3 by 2 square minus 5x square equals to 9 by 4. So this should be the solution. Okay. Yeah. Is it clear? So this should be the solution for this polar equation. Okay, so now we're gonna go to the next question. So this would be question number 2. Okay, so the question is given like this: find the value of the double integral integration 0 to 1 integration 1 to 2 x minus y divided by x square dx dy. Further, compute integration 1 to t 1 to 2 0 to 1 x minus y divided by x square dy dx, and compare uh, both the results. Okay, is it clear? Okay, so they're asking to find a double integral, which is integration 0 to 1 and 1 to 2 x minus y divided by x square dx dy. So first you do with respect to x and then with respect to y. And then they're asking again by interchanging the dx dy by dy dx. So first you do the integration with respect to y and then with respect to x, and then compare both the integration value and try to see if they are equal or not. Okay, and my guess is both should be equal. Okay, so let us try to compute the first one, which is integration 0 to 1 1 to 2 x minus y divided by x square dx dy. Okay, so first we're gonna be doing the integration with respect to dx. Okay, so this will be 0 to 1. This will be integration 1 to 2. So this will be 1 by x minus y by x square dx, and the resulting integration will be applied again on the interval 0 to 1, and then we will do the integration with respect to y. Because first, if we do the integration with respect to x, then this will be a function of x, sorry, function of y, and then we can do the integration again, and then we will get the numerical value. Okay, so this is gonna be integration 0 to 1. Now we know that the integration of 1 by x is ln x, or ln of mod x, and the integration of minus of 1 by x square is minus of 1 by x. So this is gonna be plus y by x, and this will be 1 to 2 dy. Okay, so this will be again integration 0 to 1 ln of 2 plus y by 2 minus ln of 1 minus of y by 1 dy. So this is gonna be integration 0 to 1 ln of 2, and this is y by 2 minus y, which will be y by 2, and ln of 1 is 0. So this will be integration of dy. So since ln of 1 is 0. Okay, so now we have to do this integration. So now since ln of 2 is a constant number, so we can take it outside. So this is gonna be ln of 2, sorry, ln of 2 minus integration 0 to 1 y by 2 dy. So this is gonna be ln of 2 minus 1 by 4 y square integration 0 to 1. I mean the limit 0 to 1. So ln of 2 minus 1 by 4 times 1 minus 0. So the answer should be ln of 2 minus 1 by 4. Okay, so I hope this is clear. So now let us try to do the other double integral, which is integration 1 to 2 and 0 to 1, and then x minus y divided by x squared dy dx. Okay, so this is the another part. So this is integration 1 to 2, 0 to 1, x minus y divided by x squared dy dx. Okay, so first we'll be doing the integration with respect to y, and then the resulting value will be a function of x, and then we'll be doing the integration again with respect to x. So this is gonna be integration 0 to 1, 1 by x minus y by x squared gy, and then outside g of x. Okay, so this is gonna be integration 1 to 2. This is y by x minus y squared by 2x squared 0 to 1 dx, which is same as integration 1 to 2. So now if you just put 1, so it will be 1 by x minus 1 by 2x squared. Now if you put 0, then the value of the inside value, I mean the value of inside the box will be 0 minus 0, which is 0. So this will be integration of dx, and this is ln of mod x minus of 1 by 2, and the integration of 1 by x square is minus 1 by x. So this will be 1 by 2x 1 to 2. Okay, so this is just ln of 2 plus 1 by 4 minus ln of 1 minus of 1 by 2. Okay, so this is gonna be, so ln of 1 is 0, and 1 by 4 minus 1 by 2 is minus 1 by 4. So this will be ln of 2 minus of 1 by 4. Okay, and which is same as integration 0 to 1, 1 to 2, x minus y divided by x squared dx dy. So I hope this is clear, that we can see on this region, like on this rectangular region, 0 to 1 and 1 to 2, both the integration value is equal. So that means if you interchange dx and dy, the value remains same. Now this is not a coincidence. We can even write a theorem regarding this. So it goes like this. So we can write this theorem, which is famously known as the Fubini's theorem. Okay, so yeah, let us write the theorem here. Okay, so it says let fxy be a continuous function throughout the rectangular region R. So a rectangular region R looks like this. So this is gonna be, sorry, this is x comma y, such that a less equals to x less equals to b, and c less equals to y less equals to d. Then the integration over the rectangular region will be interchangeable in terms of dx and dy. So this will be integration a to b C to D fxy dy dx, and this is also same as integration C to D a to b fxy dx dy. Okay, so a rectangular region looks like this. This is the Cartesian plane xy. So this is somewhere from a to b, and this is somewhere from C to D. So this will look like this. So we are doing integration in this region. Okay, or maybe let us draw a straight line. Yeah. So we are doing integration in this region. So this is our rectangle R. Okay. So I hope this is clear now. And if they give you and an integration over two limit value like a to b and c to d, then it doesn't matter what like which variable you do the integration first. It will always be the same, like integration a to b c to d uh, dx sorry dy dx fxy dy dx will be always same as integration c to d a to b fxy dx dy. Okay. Okay, so now we're gonna move on to the next question. Okay, so this will be question number, I hope it will be third. So yeah, this is question number 3. So it says that find the extrema of the function. So this is from the Lagrange multiplier. Find the extrema of the function f of xy equals to x square y. Okay, on the ellipse x square plus 2y square equals to 6. Okay, so this can be written as a minimization problem. So this is gonna be minimization of fxy subject to x square plus 2y square equals to 6. So it means that we have to minimize the function f of xy over the points where it satisfies this ellipse. Okay, that x square plus 2y square equals to 6. So that means you collect all those points x and y. So this is the geometrical mean. So it means you collect all the points on the ellipse which satisfying this feasibility, and then you try to minimize over this region. Okay, so yeah, and we can do it by using Lagrange multiplier. So let us denote the function x square plus 2y square minus 6 by gxy. Okay, now by Lagrange multiplier, so by Lagrange multiplier rule, we can find a lambda such that gradient of f equals to lambda times gradient of g, where lambda is a real number. Okay, so now we will just do the derivative with respect to x and y, and then we'll just make both sides equal. So since we know that f is a function here from R2 to R, so that means we have two variable x and y. So gradient of f is nothing but f of x comma f of y, which is nothing but del f del x and del f del y. Similarly, gradient of g is also g of x and g of y, which is also same as del g del x and del g del y. So now if you just multiply lambda by to the side of gradient of g, and then we make both side equal, that gradient of f and lambda times gradient of g, then both the coordinates will be equal, right? So this will imply that fx equals to lambda times g of x and f of y is lambda times g of y, correct? So now what is f of x? So f of x comma y was x square y. So f of x should be 2xy and f of y should be x square. Similarly, g of x, that means the derivative of g with respect to x, should be 2x, and the derivative of g with respect to y should be 4y, correct? Okay, so now if you just put all the values here, so let us call it 1 and let us call it 2. Put the derivatives 2 in 1, so in equation 1, and if you do so, then we'll get 2xy equals to 2 lambda x and x square equals to 4 lambda y. Now from first equation we can see that so 2 will get cancelled out. It will be x time y minus lambda equals to 0. Okay, so from here we have two choice, either x is 0 or y is lambda, and x is 0 will imply y is 0 from here. Okay, and y equals to lambda will imply x square equals to 4 lambda square. Okay, so now we know that x square plus 2y square equals to 6. So this will imply, so since x square equals to 4 lambda square and y equals to lambda, right, for the case, so here we'll get 2 lambda square equals to 6. So this is implying that 6 lambda square equals to 6, and this is implying lambda equals to plus minus 1, right? Okay, so now from here we get y equals to it was lambda, so plus minus 1, and x equals to square root of 4 lambda square, right? 4 lambda square, so this will be square root of 4, so this is plus minus 2, or we can write like this also, x square equals to 4 times 1, which is 4, so this is implying that x equals to plus minus 2. So the points are 2 1, 2 minus 1, and minus 2, minus 1, and minus 2 1. Okay, okay, so now for the second case, we can see that if x equals to 0, then y was 0. But if you just replace x equals to 0 and y equals to 0 in x square plus 2y square equals to 6, so you just replace it here, like x square plus 2y square equals to 6. So this will imply 0 square plus 2 times 0 square equals to 6, right? And this is never true because the left side is 0 and right side is 6. So that means we cannot take the second case. So the first case will be giving these 4 points. Okay. So we cannot consider the second case. So let us now just evaluate all this point of the function, and then we can decide which is keeping the maximum value, right? So that's what we have to find, right? So we have to find the extrema. I mean, it can be minimum or maximum. So let us try to see. So this will be the table. So these are points, and this is the function value. Okay. So the first point was 2 comma 1. So this will be 4. Second point is 2 comma minus 1. This will be minus of 4. Next point is minus 2 comma 1. So this will be also 4. And the another point is minus 2 comma minus 1. So this is going to be also minus of 4. Okay. So the maximum value is 4 in this 2 point, and the minimum value is, so these two are max value, and these two are the mean value. I mean, so this is giving the mean value. Okay. So we can say max of fxy over that ellipse is 4, and minimum of fxy over that ellipse is minus of 4. Okay. So I hope this is clear. And if you have any doubts, then you can always ask me, and also you can ask me in the next class, or you can go through the video again, which will be available on YouTube. Okay. So yeah. So this was question number, I hope it was third. So next question will be question number 4. Okay. So now I'm gonna be uh, solving an interesting question which was asked in GATE 2022. Okay. So the question goes like this. The maximum value of fxy equals to 49 minus x square minus y square on the line x plus 3y equals to 10 is. So this question was asked in GATE 2022. Okay, so this was a NET type question. Okay, so this is a classic example of Lagrange multiplier. So you can solve it also using the one variable. So you just replace x by 10 minus 3y and then try to minimize over x. That is also true, but we can more easily do using the Lagrange multiplier. Okay, so let us do the solution. Now we can also try to write the Lagrangian equation, and then we can do the derivative with respect to x and y, and then put both the derivatives to 0, and then try to find out the values of lambda and eventually the solution. And this is also another way to do it. There is no such, like, I mean, both are same. So first I'm going to write the Lagrangian equation. So the Lagrangian equation is going to be L of x, y, and lambda equals to 49 minus of x square minus of y square plus lambda times x plus 3y minus 10. So one thing to note here is that instead of x plus 3y minus 10, you can write 10 minus x minus 3y also. So in that case, the change of the sign of the lambda will be changed, but the maximum value of fxy would remain the same. Okay, so there should not be any confusion that why I'm writing x like x plus 3y minus 10, because our goal is to minimize fxy subject to gxy equals to 0. So now you have several choices of, I mean, you have two choices of gxy. So either you can take x plus 3y minus 10, or 10 minus x minus 3y. Okay, so just the sign of the Lagrange multiplier lambda will be changed. Otherwise, the maximum value should not be changed. Okay, so now using Lagrange multiplier, we have to put del x to be 0, and del L del y to be 0. So by the first case, now del L del x 0 will imply minus 2x plus lambda equals to 0, and this is implying that lambda equals to 2x. Okay, and del L del y equals to 0. This will imply minus 2y plus 3 lambda equals to 0. Okay, so this will imply uh, minus of 2y to be minus of 3 lambda, or 2y to be 3 lambda. Okay, so now since already we know that the points x comma y has to satisfy x plus 3y equals to 10. So let us call it as 1, and this is as 2. So the points that maximizes if has to satisfy x plus 3y equals to 10. Okay, hence from 1 and 2 we have, so just from 1 we can see x is lambda by 2, and from 2 we can see that y is 3 lambda by 2. So we're going to just replace the values of x and y here, and then we just calculate the values of lambda. Okay, the value of lambda. So this will be so x is lambda by 2, so this will be lambda by 2 plus y is 3 lambda by 2, so this will be 3 times 3 lambda by 2 equals to 10. So this is implying that lambda plus 9 lambda equals to 20, and this is implying k lambda equals to 20. So lambda equals to 2. Okay, So if lambda is 2 from 1 and 2, we have again, so x will be, so from 1 we can see lambda is 2x, so x will be lambda by 2. So lambda is 2, so this should be 2 by 2 equals to 1. And from 2, y should be 3 lambda by 2. So this should be 3 times 2 divided by 2, and 2 good cancelled out. So it should be 3. Okay. So the maximum value of fxy on x plus 3y equals to 10 is, so the function fxy was 49 minus x square minus y square. So it will be 49 minus x is 1 minus y square is 3 square. So this is gonna be 49 times 1 minus 9, which is 49 minus 10 and 39. Okay. So the answer is, so the max value of f is 39. So this is what you have to find out in the GATE exam. Okay, and this type of questions are asked every year. Uh, I don't know if this was asked in the other years like 23, 24, but I think I have came across this type of questions. So yeah, so this is a good question, I think. Okay, so now we're gonna move on to the next question. Which is question number 5. Okay, so now we'll be solving question number 5. Okay, so the question is given like this. Find out the value of the triple integral one to e cube 1 to square 1 to e 1 by xyz tz ty tx. So that means first you have to do the integration with respect to z, and then with respect to y, and then with respect to x. Okay, so yeah, so let us do it. Solution. Okay, so this will be integration 1 to e cube 1 to e square 1 to e 1 by xyz tz ty tx. This will be same as integration 1 to e cube 1 to e square 1 by xy integration 1 to e 1 by z dz ty dx. Okay, so first you're going to do the integration with respect to z, and then with respect to y, and then in the last with respect to x. So this is one integration 1 to e cube. This will be e square, right? Integration 1 to e square 1 by xy. So this will be ln of mod z 1 to e ty dx. Okay, this is 1 to e cube 1 to e square 1 by xy. Now ln of e is 1 and ln of 1 is 0. So this will never be 1 minus 0. Okay. So this will be 1 to e cube 1 to e square. Sorry, e square xy dy dx. And again, we can do the same thing. So we have to do integration with respect to the variable y. So 1 by x will be treating as a constant. And this is going to be integration 1 to e square 1 by y dy into dx. Okay. So this will be integration 1 to e cube 1 by x and then ln of mod y. The limit will be 1 to e square dx. So this is going to be 1 to e cube 1 by x. So now ln of this will be ln of e square minus ln of 1 dx. Okay. So this will be integration 1 to e cube. Now there is a 1 by x. So since ln of e is 1, so ln of e square will be 2 of ln of e, that is 2 times 1. So this will be just 2 minus of 0 since ln of 1 is 0, and this will be d of x. So integration 1 to e cube, this is going to be 2 times x t of x. So this is 2 times ln of mod x 1 to e cube. Okay. So this will be 2 times ln of mod e cube minus 2 times ln of 1. So this is gonna be 6 times ln of e minus 0, and which is 6. Okay. So this should be the answer. So integration 1 to e cube 1 to e square 1 to e 1 by xyz dz dy dx should be 6. So yeah, I hope this was the question. Yeah, 1 to e cube 1 to e square and 1 to e 1 by xyz dz dy dx should be the answer 6. Okay. So I hope this is clear, and if it's not clear, then kindly go through again. And then again, if there is any doubt, you can always ask me in the next class. So this is gonna be question number 6. Okay. So this is from the Taylor series approximation. Find out the quadratic approximation of the function f of xy is equals to exponential x ln of 1 plus y. Okay, so let me write it clearly. At the origin. Okay, so origin means 0, 0. So yeah. So yeah, let us do the solution. Okay. So the quadratic approximation using the Taylor's theorem at the point x0, y0 is given by so this is f of x0, y0 plus fx at x0, y0 into x minus x0 plus fy at x0 comma y0 into y minus y0 plus 1 by 2 times fxx at x minus x0 sorry x0 comma y0 into x minus x0 square plus fxy 2 times fxy x0 y0 x minus x0 into y minus y0 plus fyy x0 y0 y minus y0 square. Okay, so this is the quadratic approximation of a function of two variable at a given point x0 comma y0. Okay, so here x0 and y0 is just 0 0, so f of 0 0 will be to the power 0 ln of 1 plus 0, so this is gonna be 0 again. Okay, and if x of x comma y will be same as exponential x ln of 1 plus y, if y of x comma y, so this is gonna be exponential x into 1 by 1 plus y, which is just e to the power x divided by 1 plus y divided by 1 by 1 plus y, and so yeah fy 0 0 and so so from here fx 0 0 is 1 times 0, which is 0. Fy 0 0 is e to the power 0 divided by 1 plus 0, which is 1. So now we have to do fxxy. So if xy is same again, that is the derivative with respect to x of the function fx of x comma y. So this is gonna be again e to the power x ln of 1 plus y. So this will be e to the power x ln of 1 plus y. So if xx at 0 0 will be e to the power 0 ln of 1. So this is 1 times 0, which is 0. Okay, and similarly if y of x comma y, this is gonna be minus exponential of x 1 plus y square. Okay, because the derivative of 1 by 1 plus y with respect to y should be minus 1 divided by 1 plus y square. So if y at 0 comma 0, this should be negative of exponential of 0 by 1 plus 0 square, and this should be minus 1 divided by 1, and so it is minus of 1. Okay, so yeah, so now the answer should be qxy equals to, so this should be the approximate f of 0 0, which is 0 plus fx x0 y0 into x minus x0. So fx 0 0 is 0 and fy 0 0 is 1. So 0 times x minus 0 plus 1 times 1 minus 0 plus 1 by 2, and fxx 0 0 is 0. So the 0 into x minus 0 square plus 2 into x into y, I mean 2 into x minus 0 into y minus 0, and fxy fxy 0 0. So what is fxy? So fxy will be exponential x divided by 1 plus y. So fxy 0 0 will be also 1. Okay, So yeah, this is 1. So this should be 1 plus, so Fy0 0 is -1 times y minus 0 square. So this should be y plus half times. So this is 0 into x square is 0, and this is 2xy minus of y square. Okay, so this should be y plus xy minus 1 by 2 y square. So we can write the quadratic approximation should be y plus xy minus of half y square. So yeah, this should be the answer. Okay, so I hope this is clear, and if there is any doubt, you can always ask me. Okay, either in this class or in the next class. So this was question number, I hope it was 6. Yeah. So now we have question number 7. Okay, so now again we have triple integral, which we will be solving. So it's a similar type of question which we did just one question ago. So the question is given like this: find out the value of the triple integral. So it is given like this: 1 to 2, 1 to e square, 1 to e, 1 divided by x square yz, gx, gy, tz. Okay, so now this is the solution. So yeah, so first we have to do the derivative. I mean the integration with respect to x, and then the integration with respect to y, and then the resulting integration with respect to z. Okay, so this is integration. So yeah, this is the integration 1 to 2, 1 to square. So sorry, this is 1 by yz, integration 1 to e, 1 by x square, gx, and then ty tz. Okay, so this is gonna be 1 to 2, 1 to square, 1 by ez. This is minus 1 by x, 1 to e, dy dz. Okay, so this is integration 1 to 2, 1 to e square, 1 by yz. Now we have, so minus of 1 by e, minus of 1. So this is going to be plus of 1. So this will be minus time 1 by e plus 1 dy dt. Okay. So this is 1 minus 1 by e, integration 1 to 2, 1 to e square, y by 1 by yz, dy dz. And this is same as e minus 1 by e, integration 1 by 2. So now we have to do the integration with respect to y. So the z variable will be treated as a constant, and this will be integration 1 to e square, 1 by y dy, and the outside there will be dz. So this is e minus 1 divided by e, integration 1 to 2, 1 by z. So this should be ln of mod y 1 to e square dz. Yeah, this should be e minus 1 divided by e integration 1 by 2 1 by z, and ln of e square will be 2 ln e, which is 2, and ln of 1 should be 0. So this is 2 minus 0. Now this is again e minus 1 by e. So yeah, e minus 1 by e, and the integration of 1 by z is ln of mod z. There is a 2 here. This is 1 to 2. So this should be e minus 1 by e into 2 ln of 2 minus of 0, because ln 1 is 0. So the answer should be 2 ln of 2 e minus 1 by e. Okay. So yeah, this should be the answer. So I hope this is clear. Okay. So yeah. So if this is clear, then we can go to the next question, which will be question number 8. Okay. So you can go through the solution again, and if there is any doubt, you can ask me in the class, or maybe in the next class. So yeah, this is gonna be question number 8. Okay. Find the maximum absolute error uh, in the linearization of the function f of xy equals to x square minus 3xy plus 5 at 1 comma 1, and the region r equals to uh, x comma y in R2 such that modulus of x minus 1 is less equals to 0.1 and modulus of y minus 1 is less equals to 0.1. Okay. So solution. So now this is not that difficult question. So just there are some formulas. I mean, which is directly coming from the approximation of the Taylor series. Since we want the linearization, so we have to take up to the quadratic approximation, and then the quadratic term will be the error, right? So that means we have to find out modulus of R1 less equals to m by 2 modulus of x minus x0 plus modulus of y minus y0 square. Okay. So here the point x0 y0 is nothing but 1 comma 1, which is at the center x0 comma y0, and here m is the maximum modulus of fxx at x0 comma y0. So this is like modulus of if xy at x0 comma y0 and modulus of if yy at x0 comma y0. Okay, so this should be straightforward because we have all the informations such as x0 y0 and fxx fyy and fxy. So f of x is, from here you can see f of x is just the partial derivative with respect to x, so this is going to be 2x minus 3y, and then if xx will be 2 and if xy will be minus of 3. Okay, similarly fy gonna be minus of 3x and if yy will be minus of 3. Okay, so now we have to just uh, find out the values at the point 1 comma 1. So if xx at 1 comma 1, so this is 2 because the fxx is 2 throughout all values of xy. If xy at 1 comma 1 is also minus 3, and if yy at 1 comma 1 is also minus 3. So if you just take the modulus of all of these three values, like fxx, fxy, and fyy at 1 comma 1, then the maximum of m should be 3. So this is just straightforward, right? So the maximum error R1, this should be less equals to 3 by 2 x minus 1 square plus, sorry, this is x minus 1 plus y minus 1 square. So this should be less equals to 3 by 2. Now we have the region is given on R as x minus 1 less equals to 0.1 and y minus 1 is less equals to also 0.1. So this should be 0.1 plus 0.1 square, and this is 3 by 2. So this is 0.2 square. So this equals to 3 by 2 into 0.04, right? So this should be 3 times 0.02. So this should be 0.06. Okay. So maximum uh, the maximum absolute error should be 0.06. Yeah, this is the answer, correct? So yeah, and I hope this is clear. Okay, and if there is some doubt, you can always ask me either in this class or in the next class. Okay, so yeah, I hope this is clear, and you can go through the lecture videos that has been shared for week 4. So there the theory is given that how the linearization is coming. That means how to find out the Taylor's approximation of first order, second order, third order respectively, and then how to find out the error terms so that you can get the quadratic linearization or cubic approximation. Okay, and it can go on like this. Okay, so we have the next question. It should be question number 9. Okay. Uh, okay. So if the linear approximation of fxy equals to xy minus 3y square plus 2 at 1 comma 1 is given by x plus by plus c. Then find the value of a plus b plus c. Okay. Okay. So this is also straightforward. First, we have to find out the linear approximation, that is up to the Taylor series approximation up to the first order, and then we're gonna compare it with the equation given by x plus by plus c, and then we'll get our coefficient a, b, and c, and then we can just do the sum, and then we can find out the value of a plus b plus c. Okay. So as we have already mentioned earlier, the linear approximation of the function f from if f from R to R is a function, okay, then the linear approximation of f at a point x0 comma y0 is given by, so this is going to be L of xy equals to f of x0 y0 plus x minus x0 f x at x0 y0 plus y minus y0 into fy at fy into y minus y0. I mean, sorry. So this will be fy at x0 comma y0. Okay. So just we have to find out all the function values and the derivative at the point x0 y0, and then we can just put the values, and then we can find out what is Lxy. Okay. So f of x of xy. So this is gonna be so the derivative with respect to x will be y. The derivative with respect to y will be x minus 6y. Okay, and the point is given by 1 comma 1. So if x at 1 comma 1 will be 1, and if y at 1 comma 1 will be 1 minus 6, which is minus of 5. Yeah. So since here x0 y0 is 1 comma 1, so Lxy is, now what is f of 1 comma 1? So this is gonna be 1 minus 3 plus 2. So 1 minus 3 plus 2, which is 3 minus 3 and 0. Okay. So this will be 0 plus x minus 1 into fx of 1 1, which is 1, plus y minus 1 into fy of 1 1, which is minus of 5. So this is x minus 1 minus of 5y plus 5. So this will be x minus 5y plus 4. Okay. So this should be the linear approximation of this function at the point 1 comma 1. Now they have said that the linear approximation is given by ax plus by plus c. So let us call it as 1. Comparing 1 with x plus by plus c, we have a equals to 1, b equals to minus 5, and c equals to 4. Correct? So a plus b plus c should be 1 minus 5 plus 4, which is 5 minus 5 and 0. Hence a plus b plus c should be 0. Okay, is it clear? I hope this is clear. And if there is any doubt, as I always say, you can always ask me in this class or maybe in the next class. Okay. So this was question number 9, and we're gonna move on to the question number 10. Okay, so the polar equation uh, r cos square theta I equals to 4 sin theta represents which standard curve? Okay, so so it is given by r cos square theta equals to 4 sin theta. Now, as we have mentioned earlier, that we have to take x to be r cos theta, y to be r sin theta, x square plus y square to be r square, and theta to be tan inverse of y by x. Okay, so r cos square theta equals to 4 sin theta. So since in the right side we have only theta, so we're going to multiply r on both sides such that on the right side we can replace r sin theta by y. So this is going to be r square cos square theta equals to 4r sin theta. So since we know that r cos theta equals to x, so this will be x square equals to 4 times y. So this is x square equals to 4y. Okay, and this is a upward parabola, right? So this parabola looks like this. Okay, so I hope this is clear. Uh, this represent a parabola. Okay, is it clear? I hope it is clear. And if it's not, then you can always ask me in the next question in the next class. Okay. So another equation is given by r equals to tan sin theta sec square theta. Okay. Now similarly, we have to find out the Cartesian equation from this polar curve. And so since we know that sec theta equals to 1 by cos theta, so this can be written as r equals to tan sin theta 1 by cos theta square, and this is gonna be r cos square theta equals to tan sin theta, and this will imply r square cos square theta equals to tan r sin theta. Okay, now we already know x equals to r cos theta, thus we have to substitute y equals to r sin theta and x square plus y equals to r square, and theta equals to tan inverse of y by x. Okay. So this is gonna be x square equals to 10y. Okay. So the uh, Cartesian equation is x square equals to 10y. Yeah. So yeah, I hope this is clear. Now we're gonna go to the next question. This should be question number 11. Okay. So if the approximation quadratic approximation of fxy equals to sin x sin y at the origin is given by x square plus bxy, then what is the value of a plus b? Okay. So I hope the question is clear. So this is just a calculative question. It's not very difficult. So first we're gonna write the formula, like the formula for quadratic approximation of the function at point x0, y0, and then we'll just replace the values of the derivatives at the point x0, y0, and the other values in the formula directly. Okay, then we can just compare with the given equation, which is with the given approximation, which is ax square plus bxy, and then we can, by comparing, we can find out the values of a and b, and if you get the values of a and b, then we can just do the sum and then get the values of the value of a plus b. Okay, so the quadratic approximation is given like this: kxy equals to f of x0 y0 plus x minus x0 into f of x0 y0 plus y minus y0 into fy of x0 y0 plus half times x minus x0 square fxx x0 y0 uh, plus 2 times x minus x0 into y minus y0 fxy x0 y0 plus y minus y0 square fyy x0 y0. Okay, so here x0 y0 is just 0 comma 0 because it is given by the origin. So here x0 y0 is just 0 0. Okay, so f of 0 0 is sine 0, which is just 0, and f of x is cos x sine y. F of y is also same, sine x cos y. Okay, f xx is minus sine x sine y. f of xy is cos x cos y, and f of yy is minus of sin x sin y. Okay, so if x 0 0 will be 0, fy 0 0 will be also 0, if xx 0 0, this will be also 0, if xy 0 0 will be 1, and if yy 0 0 will be also 0 again. Correct. So our qxy should be f of 0 0, which is already 0. So this is 0, and then x minus 0 into 0 plus y minus 0 into 0 plus half times x minus 0 square into 0 plus 2xy into 1 plus y minus 0 square into 0. So this is just all 0, and this is half times 2xy, which is nothing but xy. Okay, now comparing x square plus bxy with 1 yields. So here clearly there is no x square, so it should be 0, and so the coefficient of xy is in 1 is 1, should be 1. Hence a plus b should be 0 plus 1 equals to 1. So a plus b is 1. Yeah, so this should be the answer of this question. So yeah, I think this is clear. Okay, so now you're gonna go on to the next question, which will be question number 12. So it is given like this: if a point P of A, B, C on the plane x plus 2y minus 3z equals to 7 is the closest to 0, 0, then find the value of A plus B, sorry, A minus B plus C. Okay, so yeah, now this is also not a typical question. So for it is given that a point ABC on the plane x plus 2y minus 3z equals to 7 is closest to 0, 0, then we have to find the value of A minus B plus C. Okay, so now what is the formula of a distance of a distance, like the formula from the formula finding the distance from 0, 0 to a plane where the point, any arbitrary point x, y, z is given. So this will be just the equated distance in 3 variable, so which is just given by this d equals to square root of x minus 0 square plus y minus 0 square plus z minus 0 square. So this is just the distance between the origin and the point x, y, z on the plane. Okay. So this is just x square plus y square plus z square. So now if a square root of x square plus y square and z square minimizes, then the d square will also minimize the same function, right? So our problem just reduces to minimizing x square plus y square plus z square, subject to x plus 2y minus 3z equals to 7. Okay. So the Lagrangian in this case will be in this case, so L of x y z lambda equals to x square plus y square plus z square plus lambda times x plus 2y minus 3z minus 7. Now by using the Lagrange multiplier, we can say that del L del x 0, del L del y is also 0, and del L del z will be also 0. Now del L del x equals to 0, this will imply 2x plus lambda is 0, and this is implying x to be minus lambda by 2. So let us call it as 1. Similarly, del L del y equals to 0 will imply 2y plus 2 lambda equals to 0, and this will imply y to be minus lambda. Let us call it as 2, and del L del z equals to 0 will imply 2z minus 3 lambda equals to 0, and this will imply z equals to 3 lambda by 2. Now let us call it as 3. Okay. So now we can put the values of 1, 2, and 3 into the feasibility set, which is x plus 2y minus 3z equals to 7. So putting 1, 2, and 3 into x plus 2y minus 3z equals to 7, we have, so this will be minus of lambda by 2 plus 2 times minus of lambda minus 3 times 3 lambda by 2 equals to 7. So this will imply minus lambda by 2 minus 2 lambda minus line lambda by 2 equals to 7, right? So this is gonna be minus of 2 lambda minus of 4 lambda, sorry, minus of lambda minus of 4 lambda minus of 9 lambda equals to 14, and this is implying minus of 14 lambda equals to 14, or lambda equals to minus 1. Okay, so now we can just put the values of lambda in 1, 2, and 3. So putting the value of lambda back into 1, 2, and 3, we obtain. So first x was minus lambda by 2, so this will be x equals to minus 1 by 2. Y was minus lambda, so y will be minus of 1. Sorry, this will be plus, because lambda is minus 1, so x will be 1 by 2. Y is 1, and z will be minus 3 by 2, as lambda is minus 1. Okay, so the minimum value Okay. So in the question it was given that the we have to find the point A, B, and C such that the plane is closest to 0, comma 0. Okay. So since we have got the point uh, x equals to 1 by 2, y equals to 1, and z equals to minus 3 by 2. So this is going to be our ABC. So this will be a equals to 1 by 2, b equals to 1, and c equals to minus 3 by 2, right? So a minus b plus c, this should be half minus 1 minus of 3 by 2. So this should be minus of 1 by 2 minus of 3 by 2. So this is minus of 4 by 2, and this is minus of 2. So a minus b plus c should be minus of 2. And the minimum of the value fxy equals to x squared plus y squared plus z squared on that plane. So this is going to be 1 by 2 square plus 1 square plus minus 3 by 2 square. So this will be 1 by 4 plus 1 plus 9 by 4. So this is 1 plus 4 plus 9 divided by 4. So this is 14 by 4. So this should be 7 by 2 or 3.5. Okay. So the value of a minus b plus c is minus 2, and the minimum value is c 3.5. Okay. So I hope this is clear, because we have to just find the value of x, y, z, that is minimizing the point x, y, z from 0, comma 0. So this should be 0, comma 0. I mean, so in the question it was 0, 0, 0. So not only 0, 0. So this should be 0, 0, 0, because here we have three coordinates, right? X, y, and z. So it should be 0, 0, 0. Okay. So yeah. Now we're gonna go on to the next question. So this is gonna be question number what? 13. Okay. So trace the polar curve uh, r equals to a time 1 plus cos theta, where a is theta. Okay. Okay. So let me write it in red color. So trace the polar curve r equals to a times 1 plus cos theta, where a is greater than 0. Okay. So this is solution. Okay. So in polar coordinate system, if this is a point p of r comma theta, so suppose this is p of r theta. So yeah, this angle is theta here, and this distance is r. Okay. So now to trace the polar curve, first what we're gonna do is we check the symmetry around the x-axis and the y-axis. So first we check the symmetry around theta equals to pi by 2. And this is actually theta equals to pi, correct? And this is theta equals to 3 pi by 2, right? Okay. So uh, yeah, this should be 3 pi by 2. So yeah, so first to check the symmetry at theta equals to pi by 2, that is the symmetry around the like with respect to the y-axis. So this is gonna be our point. This is just uh, r comma pi minus theta. Okay. So if a function r equals to if theta is given, then uh, f of theta should be same as f of pi minus theta. Now, if this holds, then we can say this r is symmetric. I mean, the curve is symmetric. Then I can say this r is symmetric about the y-axis, or theta equals to pi by 2. Okay. Now, similarly, to check the symmetry about the x-axis, you have to just check PA to be. So this will be r comma minus theta. So this is symmetry about the line r equals to 0. Okay. Okay. So not r equals to 0. This is symmetry about the line theta equals to 0. So if f of theta equals to f of minus theta, then symmetric, the graph is symmetric about x-axis, or we can say theta equals to 0. Okay. And if uh, so this is another point which is minus r comma theta, and if that the values of this graph r equals to f theta is same as the as in the point minus r comma theta, then we can say that the curve will be symmetric with respect to the origin. Okay. So now let's come to the question. So first we'll check at theta equals to 0. So this is about the x-axis. So this is x-axis. So we have to just replace theta by minus theta. So let us replace by f of minus theta. So this will be a plus 1 plus cos of minus theta. Now since cos of minus theta is cos theta, so this will be 1 plus cos theta, and this is f of theta, which is r. So the graph is symmetric about the theta equals to 0, or the x-axis, or x-axis. Okay. So now also we can check at theta equals to pi by 2. Theta equals to pi by 2 means replace theta by pi minus theta. So that means we're trying to check the symmetry with respect to the y-axis. So f of pi minus theta gonna be a times 1 plus cos of pi minus theta. This will be a times 1 plus sine theta, and which is not equals to f of theta. So clearly the graph is not symmetric about the y-axis, or the line theta equals to, I mean the angle theta equals to pi by 2. Okay. So about the pole, or the origin. So here minus r equals to a times 1 plus cos theta, and clearly this is not same because it was r equals to a plus 1 plus cos, a times 1 plus cos theta. So this is so our polar curve is symmetric about only theta equals to 0 or x-axis. Okay. So remember our curve was given like this: r equals to 1 plus r equals to a times 1 plus cos theta. Okay. Now r equals to 0 will imply 1 plus cos theta equals to 0, and here a was greater than 0. So this will imply that cos theta is minus 1 or theta equals to pi. Okay. So now let us try to check some points of theta and r. Then we can try to see what's going on. So this is theta, this is r. So at theta equals to 0, we can see this is this will be 2a. So the maximum value will be of r will be 2a, because r equals to a times 1 plus cos theta. So the maximum value of r will be 1 plus 1, this is 2 into a, which is 2a. And the minimum value of cos theta is minus 1. So in that case, the minimum value of r will be 0, right? And at 0, it is 2a. At pi by 2, cos pi by 2 is 0. So this should be a. At pi, it should be 0 because cos pi is minus 1. And at 3 pi by 2, it should be a. And at 2 pi, it should be 1 again. So it should be 2a. Correct. So now we can try to draw the graph. So this is our theta equals to 0, 2 pi, and so on. So this is theta equals to pi by 2, and this is theta equals to 3 pi by 2, and this is theta equals to pi. Correct. So at theta equals to 0, it is 2a. Correct. So somewhere here, which is r equals to 2a. Correct. And when theta equals to pi by 2, the value is giving as a. So this will be somewhere here. Correct. And at the values of pi, it should be 0. Correct. So that means it will be somewhere here. And remember, it was symmetric about the x-axis. So that means if this is the first graph, so this should be the another part of the graph. Correct. So this is our graph r comma if theta. Okay. This is famously known as cardioid. So this is called cardioid. Okay. So this is called cardioid. Okay. So yeah, I hope this is clear. Okay. So now let us try to see another graph which we'll try to trace. So this is gonna be question number 40. So this will be question number 40. Okay. So I hope the previous question is clear, because so first so if a polar curve is given, then first we will try to find out the symmetry, like about the origin or about the x-axis or about the y-axis. And for origin, we'll just replace by r to be by minus r. And if it's about the angle theta equals to pi by 2 or y-axis, then we'll replace theta by pi minus theta. Then if the both values are equal, then we can say the graph is symmetric about the y-axis or symmetric about the angle theta equals to pi by 2. And then also we'll try to find out the symmetry about the x-axis by just just replacing theta by minus of theta. And if like f of theta equals to f of minus theta, then we can say that about the line theta equals to 0, the curve is symmetric, or in Cartesian coordinate, it is symmetric about the x-axis. Okay. So then after the symmetry, we can try to find out the range of A, the range of R for different values of theta. So it can be find out easily if it's like in terms of cos theta and sin theta, because we know the minimum and maximum value of cos theta and sin theta, and then we can try to plot some point or try to draw the tangent, and then we can try to see like what sort of graphs are coming. Okay, so it depends on the question instance. So I hope this is clear. So let us try to see another question, then I think this topic will be clear. Okay, so trace the curve of the graph. So let's trace the curve of r equals to a times sine of 3 theta, where a is greater than 0. Okay, so yeah, so let us try to do the solution. So first we're gonna try to see the symmetry. So yeah, first try to see about symmetry about the line theta equals to pi by 2. Correct. So theta equals to pi by 2 means we have to check f of pi minus theta. So this is gonna be a times sine of 3 of pi minus theta, which is a times sine of 3 pi minus 3 theta, and this is gonna be same as sine of 3 theta. So this is f of theta. Okay, so here r is f of theta. So from here we can see that it is indeed symmetric about the line about y-axis, or about theta equals to pi by 2. So now let us try to check around theta equals to 0. So then we have to check f of minus theta, which is a times sine of minus of 3 theta, which is a times minus sine of 3 theta. Okay, and this is not equals to f of theta. So the curve is not symmetric about the line of theta equals to 0, or the axis, and not symmetric about the angle theta equals to 0, and not symmetric about the x-axis. Okay, so yeah, so I think this is clear now. And again, if you just try to replace r by minus r, so this it will be minus r equals to a times sine of 3 theta. So clearly from here we can see that it is also not symmetric about the origin, right? So our curve is symmetric about theta equals to pi by 2. Okay, and yeah, so now if you just put r equals to 0, then we can see. So remember r was a sine 3 theta, where a was greater than 0. So r equals to 0 will imply sine of 3 theta is 0. So this will imply theta equals to 3 theta equals to k pi, or theta equals to k pi by 3. Okay, so that means the values are 0, pi by 3, 2 pi by 3, and so on. Okay, to notice here is that the value of sine 3, the maximum value of sine 3 theta is 1, and the minimum value of sine 3 theta is minus 1. So r lies between minus a and a. Okay, so as sine 3 theta as minus 1 is equals to sine 3 theta is equals to 1. Okay, so now we can try to plot some points and see what's going on. So this is theta, this is r, so this is 0 0, and at the point pi by 6 it will be, so it will be 3 times pi by 6. So it will be pi by 2. So it should be a. At the point pi by 3, it should be 0. At the point pi by 2, it should be 3 pi by 2, which is minus of 1 and then minus of a. And similarly at 2 pi by 3, 0. And 3 pi by 2 again. Should be 9 pi by 2, and sine of 9 pi by 2 is sine of 4 pi plus pi by 2. So this should be pi by 2, so which is 1. So it should be again. Okay. So yeah, this should be the points with the function value. I mean, the value of r is given like this. So now we can try to draw the graph. So at r equals to at theta equals to 0 and r equals to 0, this is 0. So remember, the graph is symmetric about the y-axis. I mean, about the line theta equals to pi by 2. So now you see that at pi by 3, so at pi by 6, this is becoming a. So this is somewhere here. So this is somewhere here, and this is a. So that means this is at pi by 6, this is a, and pi by 3 is again becoming 0. So that means if you just give a round here, this will become, so at, so somewhere here. So this is somewhere here a. Okay. And similarly, since this is symmetric about the y-axis, there will be another graph here. Okay. And again, pi by 2, this value is minus a. Correct. So that means uh, in the downside, there will be another graph, similar type of graph. Okay. So I hope this is clear now, because if we just plot the point like pi by 2 or another point like 5 pi by 2, so then you will get the values like minus of a. So that means this will be the graph of this function r equals to a sine 3 theta, where a is greater than 0. Okay. So here it will give the value minus of a. So let me draw the graph nicely. So this will be the graph. Okay. So this should be the value a, and this should be the value minus a, and this will be also a. Okay. So yeah, I hope this is clear now. And if you have any questions, then you can always ask me in the next class. So please go through this video again, or maybe particularly if you have any doubts or any question, go through all the video and try to solve some questions so that the concepts will be clear to you. And I think then you'll be able to solve all the assignments. So yeah, so yeah. Thank you. See you in the next class.